Hi viewers, I'm Emmanuel Johnny by name. Now in this video, I'm going to be providing solutions to Math 121 past questions. This is 2022-2023 past question. So if you're preparing for the 2024-2025 Math 121 examination, this past question is for you. Okay. Now, in 2022-2023, one of the questions that was asked is that you should find the value of the limit as x tends to infinity of x cubed minus 8 all over x squared minus 4. Now, as far as limit of a function is concerned, and you want to find the limit of a function as x tends to infinity, there is a very simple way to go about it. Don't forget, there's always objective examination. You don't have to show full working. You just have to, find a very simple way to provide solutions to them. So this is what you do. Limit as x tends to, this is the question, but I want to use this to explain to us the easiest way to get the answers without having to solve. So this is what you do. 1. You look at x cubed plus 2x squared minus 6x plus 2 all over 2x cubed plus 3x squared minus 4x plus 3. Now, the highest degree of the numerator is 3 and the highest degree of the denominator is 3. When the highest degree of the numerator and that of the denominator are the same, what do? The answer is simply, what is the coefficient of x cubed at the numerator? The coefficient of x cubed is 1. So look at it here, 1 all over. What is the coefficient of x cubed at the denominator? It is 2. Look at it. So all over 2. That gives you the answer to this problem without solving. But if the degree of the numerator is smaller than the degree of the denominator, as you can see, it's like saying 2. That of the numerator is 3. I'm dealing with the degree now. All over 3. Look at this one now. The degree of the numerator was 3. All over. The degree of the denominator was 3. All over 3. So the degrees of the numerator and that of the denominator are the same. So we now take the coefficient of the highest degrees. That's 1 over 2. But here the degree of the numerator is smaller than the degree of the denominator. The answer without solving will simply be 0. But if the highest degree of the numerator and is bigger than that of the denominator, for instance, we have 3 there, all over 2, then, in this case, this is proper fraction, this is improper fraction. So when it is improper fraction, the answer is simply infinity. Or you can use the word undefined. Undefined. So that is just the easiest way to get answers to this problem without solving. Of course, there is a long method to solve it, but this is the simplest way to get the answers. So, with that understanding, we now go back to the question that was asked. And the question is, what is the value of limit as x tends to infinity of x cubed minus 8 over x squared minus 4? Now, if you see, the highest degree of the numerator is 3 and the highest degree of the denominator is 2. So that's like 3 over 2, which is improper fraction. So what do you think will simply be the answer from what I have illustrated before now? The answer is simple, undefined, because the highest degree of the numerator is 3 and that of the denominator is 2. That is improper fraction. So the answer is simply undefined, option D. So that's exactly how to provide solution to that question. Let's look at another problem. Okay, so this is example, question number 2. It says, evaluate f composition g. This is composition of function now. F composition g if f of x is equals to 2x squared plus 5 and g of x is equals to cos into x plus h. So this is the question is from composition of function. And I want to believe you might have learned this before now, but we want to just go straight to providing answer to the problem. So I have f of x to be equals to 2x squared plus 5. And I have g of x is equals to cos into x plus h. This is polynomial function and this is trigonometric function. Now, what do we mean when we say composition? Without wasting of time, f composition g is simply carry the function g and put it inside f. It is as simple as that. So here's my question. What is g function? G is cos x plus h. So you are going to carry the whole of g and then go to the function f and put it inside f. So what is g? Cos x plus h. When you go to the function f, anywhere you see x, put the whole of g. So look at it. These two, remember, everything here will enter here. So these two, look at it here. This x, look at it. It will open up. This x here, the x alone opens up and swallow everything in g. That is to say, I'll carry cos into x plus h, put it inside this x. So I'll have cos into x plus h. Okay, because of this bracket here, I'll use this bracket. So what did I do? I carry everything in g and I put it inside x. Now, don't forget that x has power 2. So look at it here, power 2. Then plus 5. We have plus 5. That's how to carry out composition of function. It is as simple as that. Then f composition g will be equals to, please remember, in trigonometry, if I have sine square x is the same thing as sine x all raised to the power of 2. In other words, when this power comes into the bracket, like you studied in indices, that if I have a b raised to the power of x, that when this x comes into this bracket, it will take the power of a and also takes the power of b. So I'll have a raised to the power of x and b raised to the power of x. So the same thing here, I have sine x squared. When this square comes in, we are going to have sine square and then x. You then, of course, in trigonometry, you cannot square the angle. So it just remains sine square and then x, which is what we have here. So in a nutshell, sine square x is the same thing as sine x all raised to the power of 2. Likewise, if I have maybe cos square x, is the same thing as saying cos x all raised to the power of 2. So that's the same principle we are going to apply here to get the final answer to this problem. So these two, look at it here. And then this power 2 will come in. Then see, what I had here was sine x. What I'm having here is cos into x plus h. So don't mind whatever is here. The most important thing is that whatever is here is in the angle position. For instance, the angle position here is x. Now the angle position here is x plus h. So it's just one thing. So in other words, when the power of 2, this power now 2 comes into the bracket, we'll just have cos and then square. So look at it. This 2, look at it. And then this power 2 will square this cos. So I have cos square. Then the angle now is x plus h and then plus 5. That gives you the final answer. So that is option B in this past question. Okay, so this question number 3 from this past question. It says find the range of the function x plus 2 over x minus 1 And these are the options. So without waste of time, we have the function. A function is always f of x equals to x plus 2 all over x minus 1. So here is the function. And we want to find the range of this function. Please note, first of all, that this is a rational function. Already we know the rational function is a function in fraction form whose denominator cannot be 0. For instance, 0 over 2 is 0, but 2 over 0 is undefined. So, when the denominator of a fraction is 0, it is undefined, meaning it doesn't exist, doesn't make sense, is undefined. So, when we say domain of a function, it has to do with a set of input values of x, but range has to do with the set of output values of y. So here the question says we should find the range of this rational function. So the question is, how do we find the range of rational function? Step 1, find the inverse of this rational function. Find the inverse. Please, these are steps to find the range of rational functions. Step 1, find the inverse of this function. Now, you already know how to find inverse. How? Set the function to be y equals to x plus 2 all over x minus 1. Step 1, we want to find the value of x. That's to say, make x the subject of formula. So what do? We cross multiply because this is a fraction. This over 1. Cross multiply. So this is y times x minus 1. Y into x minus 1 equals to 1 times x plus 2, which is x plus 2. Now open the brackets at the left hand side. Y times x is xy. Y times minus 1 is minus y equals to x plus 2. Now don't forget, I want to make x the subject of formula. So from here, I will collect like terms. In other words, let all x be on one side and any term without x to be on the other side. So I have xy. X will move to this side and become minus x equals to 2. Look at it. Then minus y will move to the right hand side and become plus y. I want to make x the subject of formula. X is here, x is here. I'll factor out one x. So look at it here. When I do that, what I'll be left here will be y, then minus. Having factored out x, I'll be left with 1 equals to 2 plus y. I'm looking for x. So make x the subject now, meaning that x will be equals to 2 plus y minus y minus 1. That will be all over this x. Look at it here. So y minus 1 will move to this side. I'll have y minus 1. So the last step is interchange the position of x and y. This is how to find inverse of a function. So if you interchange that, here will be y now equals to 2 plus this will be x all over x minus 1. So after interchanging the position of x and y, that gives us the inverse of the function. So the function f of x was equals to x plus 2 all over x minus 1. And then its inverse, that is f inverse of that function, is what? X plus 2 all over x minus 1. X plus 2 all over x minus 1. So we have been able to find the inverse of that function. Having obtained the inverse, the next thing now is for us to find the domain of the inverse function. And of course, a domain is a set of input values of x. Input. All right. To find the domain of this function, of course, you know that the denominator cannot be 0. Very important. So if this function must exist, it means that x minus 1 cannot be equals to 0. Meaning that x cannot be equals to 1. Because if you put 1 here, 1 minus 1 is 0. That makes it undefined. So, but this one here becomes the critical point of this function, where you put on the number line here 1. This is from negative infinity to positive infinity. Then we pick values and check for which region will satisfy this function. Let's pick a value. After 1, you have 2. So if I pick 2 here, I put it here. 2 minus 1 is 1. That means the function is defined. That means this region will satisfy the function. Let's pick a number at the front of 1. Let's pick 0. If you put 0, 0 minus 1 is minus 1, and it is defined. So this region is defined. But let's check at that critical point itself, 1. Pick 1, put 1 minus 1 is 0, which makes this function undefined. That means this region will not be satisfied. So that means that the domain of this function is from negative infinity to 1. But note that 1 is not inclusive. So we use an open bracket. And from 1 to positive infinity. From 1 to positive infinity. And you know that 1 is not inclusive. That is why it is opened. So this is the domain of the inverse function. So the domain of this inverse function, this particular domain of the inverse function, becomes the range of this rational function. So this is the range of this particular function. So if you go to the options, that will be option C. That's how to solve the problem. Okay, question number 4, still from the 2022-2023 past question. It says we should find the derivative of the function y equals to sine into x squared plus 3x minus a. Okay, looking at the function here, this is trigonometric function. And how do we differentiate trigonometric function? So I'm going to differentiate in this using a the shortcut. I will use the shortcut. But before then, let me say I have a function y is equals to sine 2x. You know, on a normal, if you want to differentiate a trigonometric function, you will have to use a chain rule to differentiate this function. But we are going to use a shortcut. How do we use shortcut to differentiate trigonometric function? Step 1. So this is dy dx is equals to, go to the angle position. What do you have there? A polynomial function 2x. Differentiate 2x. What's the derivative of 2x? Of course, you know that the answer is 2. So look at it here, 2. What's the derivative of sine? The derivative of sine is cos. And then repeat the polynomial function 2x. That's exactly how you differentiate a trigonometric function. So let's say I have y is equals to sine into 3x plus 2. Then that means that dy dx will be equals to, the trigonometric function is 3x plus 2. And what's the derivative of 3x plus 2? The answer is 3. How? If you differentiate 3x, you have 3. Differentiate a constant, you have 0. Okay? So then what's the derivative of sine? It is cos into, repeat the polynomial function, 3x plus 2. That's how you differentiate trigonometric function. And what I just did now is exactly how you are going to differentiate this given function here. So let's dive into the question proper. So we are given that y is equals to sine into x squared plus 3x minus a. Please note at this point, this a is a constant. You can assume it to be 3, 4, 5, any number at all. And of course, you know that the derivative of a constant is 0. So that means that if you differentiate this a, the answer will be 0. All right. So it means that dy over the x, without waste of time, is, differentiate the polynomial function here. So the derivative of x squared is 2x. That is 2 times 1, 2. Subtract 1 from the power. Then plus the derivative of 3x is simply 3. You are done differentiating the polynomial function. Now differentiate the trig. What's the derivative of sine? it is cos. Then into, you repeat the trigonometric, the polynomial function, x squared plus 3x minus a. That is exactly how you get this done. And that is option A. Sorry. Option B. Yeah, 2x plus 3 cos into x squared plus 3x minus a. So option C is the correct option. C is the correct option. 2x plus 3 into cos x squared plus 3x minus a. That is the correct option, C. Okay. This is another question from the past question. It says, find the derivative of the function. So the function y is equals to 1 over ax plus 1 raised to the power of 3. This function now, as it is a rational function, but we know from the idea of indices, or from the knowledge or laws of indices, we know that if I have 1 over 2 raised to the power of 3, that's fraction, the negative law, the negative of form of this number, Power's law of this fraction will be, pick the denominator, that's 2 raised to the power of 3. Mathematically, what is 1 over? 1 over is this small negative sign here. So you put it here. All right. What that means is that if this is in fraction form, this is the negative powers form of it. But I can also take it from this form back to this form as how? This small minus is 1 over. Then I'll be left with 2 raised to the power of 3. I bring it down. That gives me the same thing as this. So meaning that if I have 1 over 2 raised to the 1 over, say, 3 raised to the power of 5, I can write this as the denominator here is 3 raised to the power of 5. Then 1 over is minus, I put it there. It's as simple as that. Applying that knowledge or that concept, I can rewrite this to be, this implies that y will be equals to, this 1 over is small minus, right? So the denominator is ax plus 1 raised to the power of 3. Look at it, ax plus 1 raised to the power of 3. Then 1 over is this minus here. So this is another way I can write this. Then this now gives us what we call chain function. So we are going to use chain rule to differentiate this, and I will use the shortcut. How do we differentiate chain function? Now, this is the function I'm differentiating. It means that dy over dx will be equals to, okay, for further clarity, if I have a function y is equals to maybe 2x plus 3 raised to the power of 4, then automatically dy dx will be equals to, step 1, bring down the power. Here is this 4. Step 2, differentiate what is inside the bracket. The derivative of 2x plus 3 is 2. Of course, if you differentiate 2x, you have 2. If you differentiate 3, you have 0. So it's 2. Look at it, times 2. Step 3, repeat the bracket, which is 2x plus 3. Step 4, subtract 1 from the power. So 4 minus 1 will give you 3. So 4 times 2 is 8 into 2x plus 3 raised to the power of 3. This is the answer to this particular function. So we are going to use the same concept in differentiating this particular function. So y is equals to ax plus 1 raised to the power of minus 3. Step 1, bring down the power. So the power is minus 3. Look at it, minus 3. Step 2, differentiate the bracket. What's the derivative of ax? It is a, because if you differentiate x, you get 1. 1 times a is a. And then if you differentiate 1, you have 0. So that means that the derivative of ax plus 1 is simply a. Step 3, repeat the bracket, which is ax plus 1. Step 4, subtract 1 from the power. So minus 3 minus 1 will give you minus 4. Step 1, bring down the power, minus 3. Step 2, differentiate the bracket, you have a. Step 3, repeat the bracket, here it is. Step 4, subtract 1 from the power, you have minus 4. So it means that dy dx is equals to minus 3a, okay, times this small minus here, don't forget what we did earlier, will be 1 over. This small minus here is 1 over. Then I'll be left with ax plus 1 raised to the power of 4. You bring it down. Ax plus 1 raised to the power of 4. So this is equals to minus 3a times 1 is minus 3a all over ax plus 1 raised to the power of 4. So that is option B. Minus 3a all over ax plus 1 raised to the power of 4. That's exactly how to get that done.